All right, so we can convert these coordinates between polar and Cartesian, okay? So a point in polar coordinates, let me write this differently, that looks a little janky. A point with polar coordinates is r theta, has Cartesian coordinates x, y. All right? So you can have a polar coordinate and you can have Cartesian. You can move them back and forth. Now, polar coordinates are circular. So what do you think we're going to do to make those conversions? Yes. What did we do with our circles whenever we were talking about parametrics? Yup, same thing is happening right now. So x is equal to r cosine theta. We're using sine and cosine. Our circular functions, that's how we're making these conversions. R is going to be my radius, just like we have our radius now, and we have theta. So we're converting between radius, theta, and polar. So you have these polar coordinates. Okay, now, if I have it in polar and I want to switch it to Cartesian, that's what we use. If I have a point with Cartesian coordinates, x, y, and I want to convert that to polar coordinates, r theta, then we have to use a little thing called a circle conversion, right? So this is about the origin. So x squared plus y squared is equal to r squared. That's my circle about the origin. And then in order to get theta, so that's how I'm going to get my radius. But in order to get theta, we have to use tangent because that deals with both x and y. Okay, so theta, you can get theta by using tangent because it deals with both x and y. And then you use the circle coordinates. All right. Okay, how much room do I have on here? Oh, plenty of room. Okay, so let's do some conversions then. Here's example 2. I want to convert between the two. That's what we're looking for. All right, so polar to Cartesian. I have my point is 3 pi over 4. So I know that this is my radius and this is theta. All right. Okay, so in order to make these conversions, I want to come up with my x and my y. So my x here is going to be r cosine theta. So I have my x is equal to 2 cosine of 3 pi over 4. You're literally just plugging that in. So x is now equal to 2 times the cosine of 3 pi over 4. Well, where is 3 pi over 4? Right? It's back over here. This is my 3 pi over 4. So I know that I have the coordinate point negative and positive. So I now have 2 times the cosine of 3 pi over 4, which is negative square root of 2 over 2. So the 2's cancel, and I'm just left with x is equal to negative square root of 2. Then you do the same thing for y. So y, so there's my x, y is equal to r sine theta. So my radius is the same at 2, and then I have the sine of 3 pi over 4. So y is now equal to 2 times the square root of 2 over 2, and it's positive. The 2's still cancel, and I have the square root of 2. So my coordinate point here that I'm looking at is going to be negative square root of 2, positive square root of 2. That's my coordinate point. Now let's talk about this for just a second here. Look at this. X is negative, y is positive. I'm talking about the exact same point. The biggest difference right here is the fact that this radius is a 2 according to my polar point. But it's still over here in this quadrant, right? And in this quadrant, x is negative, y is positive. X is negative, y is positive. Same quadrant. We are representing the same point in two different ways, as polar and as Cartesian. I'm not talking about anything different. This coordinate point and this coordinate point are exactly the same. All right? Okay. Oops. Now, let's swap back and forth between Cartesian to polar. Example 2 also. Cartesian. And switch that over here to polar. So I have the point 1, negative 1. So my point here of 1, negative 1, this is the x and this is the y. So my converter, r, x squared plus y squared is equal to r squared. And the tangent of theta is y over x. So you literally plug that stuff in then, right? That's all you're doing. So I now have 1 squared plus negative 1 squared is equal to r squared. So 2 here is equal to r squared that I'm looking at. So r is equal to the square root of 2. And you're going to keep this positive, and I'm going to keep it positive because I'm talking about a radius. If it were negative, it would be the reflection, right? So technically I do have positive and negative 2, but I want to look for that primary one, not the reflection. So we're going to keep this positive. All right. Then I look at tangent. So the tangent, I'm going to bring it over here. That's too cramped. So over here, I'm going to have the tangent of theta is equal to negative 1 over 1. So the tangent of theta is negative 1. So I want to know, where is the tangent of theta equal to negative 1? Now keep in mind, what do we know about inverse tangent? Inverse tangent here, because that's what we're really trying to find, right? Inverse tangent here of negative 1 is equal to theta. Inverse tangent goes from negative pi over 2 up here to pi over 2. All right? And here's the other thing that we're talking about. Which quadrant are we in? Yeah, right? So take a look at this right here. If I'm looking at this point as over here of 1, negative 1. Here's my point, 1, negative 1. I'm digging down over here in this fourth quadrant. My angle has to also be in that fourth quadrant. So that's really what I'm looking for. Where is my angle measurement? Where does this have to go? Tangent is happening over there in that fourth quadrant. And that's what I want. I'm going to get this out of here because I'm afraid that's going to be even more confusing. So focus on this. Yes, that's all true. But focus on this part of it because I think that is that way you can hone your skills in better. We're representing the exact same point. So theta here is negative pi over 4. And that's where we get that. Because of our inverse tangent stuff and the fact that it's over here is more than anything. So what's another way to represent that? At negative pi over 4. So if I get that value, I now know that this is also the coordinate point. Square root of 2, negative pi over 4. But remember with polar, we can represent those multiple ways. What's another way to write that? Square root of 2. If I bring it out to here, what's this one? Yeah, 7 pi over 4. Because remember, you can write it multiple ways for those polar coordinates. So yes, it gets at me at negative pi over 4 right here because that's my inverse tangent. That's this quadrant. We've got that. All right, but then that's the other thing. All right, good. So we can swap back and forth between polar and Cartesian in order to pull this off, and hopefully it makes sense. So point to point, we can pull that off and we can work it through. I'm going to go to the next page. What if I have this? Example 3. I want to go from polar to Cartesian and describe the graph. So not only can we do this with points, but we can also do this with equations. Now look at what I have. R is equal to 10 cosine theta plus 24 sine theta. Go to your toolbox, guys. Remember how we talk about this toolbox all the time. Go to your toolbox. What's in your toolbox? What do you know about the relationships between polar and Cartesian? Well, I know that x squared plus y squared is equal to r squared. Yup. I know that x is equal to r cosine theta. I know that y is equal to r sine theta. Do you think any of that could be helpful? Yeah, I think so too. Look at what's going down over here. This looks helpful because I have an r and an r, right? And I have a cosine and I have a sine. I have a cosine and a sine. The biggest thing that I'm missing is I'm missing an r from here and I'm missing an r from here. So let's put one in. I'm going to multiply this entire equation by an r. So now I have r squared is equal to 10r cosine theta plus 24r sine theta. And that's where the money happens. That is the same thing as x. That is the same thing as y. And that is the same thing as x squared, y squared. I just converted all of my r's and thetas into x's and y's. So I have x squared plus y squared is equal to 10x plus 24y. Now, when you have this x and y, and we have these sines and cosines, so that's a pretty good tip off for doing something circular here also, right? Especially with everything being so squared out. You want to set this equal to 0, and we're going to complete the square. So combine your x's together. So I have x squared minus 10x plus a y squared minus 24y equals 0. When I'm looking at this, you want to put this into center radius form. That is x minus h squared y minus k squared is equal to r squared. Remember we talked a little bit about that when we were talking about parametric? Same thing. But in order to set this off, we're going to have to complete the square to find each one of these. That's no big deal. We got that. X squared minus 10x plus blank, y squared minus 24y plus blank. I like to put my plus blanks in there because it keeps me set. If you add something to this side, you also have to add it to the right side because you want to keeping it balanced, right? That's an equal sign. Both sides are equal. Well, do it then. Here, completing the square, remember you take your middle term, divide it by 2. So if this is my b term, I'm going to divide that by 2 and then square it. And that's completing the square. We're just taking something and making a perfect square trinomial out of it, right? So if I have my b here of negative 10, when you divide that by 2, you get a negative 5. If you square that, you get 25. Or you can just do it like this. And 25 is what goes in the blanks. Because this is x minus 5 squared. You divide it by 2 to get there, and then you square it to get that. The sign stays the same. Now look at what's happening. So go backwards with it if you need to. Square the first term, multiply them together by 2, and then square the last term. Right? You're just taking something that's a trinomial and factoring it. All right, look at the next piece. plus, and for your y, I know it's going to be a minus sign. Take 24, divide it by 2, gives you 12. When you square it, it's 144. Whatever you do to one side, you have to do to the other. Now, why in the devil did I put a 10 over there on that side? You guys are probably hollering at me. Good job if you were. That's a 0. This is a 0. That's a 0. Okay? Then you add those up. So this equals 169. Well, that's handy, isn't it? So if I'm looking at this, I now have center radius form. My circle, if I'm describing this, I have a circle with a center of 512. Notice my formula is a minus here, so I just go with the 5 and the 12. And I have a radius of 13 because the square root of 169, with that being squared, is 13. Okay? All right. So if you have that sine, cosine, you're setting this up, go with what's in your toolbox and work with that. You've got it. Okay. Let's do one more like this real quick. Just because I think you're practicing in that completing the square, it may have been a while since you've seen that. So here's another of example 3. So r is equal to 6 sine theta. Again, we're going to go polar, I didn't write it, sorry, to Cartesian and describe. Okay, so now here I have sine. So if we go back to our toolbox, I'm going to scoot this down a little bit. Let's come back up here to our toolbox. Sine here gets this, and r gets up here, but we're in the same boat where we have to multiply in order to get that additional r in there. Before I can get r squared is equal to 6r sine theta. I'm going to make this big again. I go with the y, and the x squared plus y squared sets me up. So x squared plus y squared is equal to 6y. Now in this instance, I don't have that additional x, but it's still a circle. So we're just going with the, subtract that over. I've got x squared, there's nothing else I'm going to do with that, plus y squared minus 6y. I'm going to go ahead and put in these blanks so that I can complete the square. X squared has nothing with it. Y minus 6 divided by 2 is 3. When I square that, it's a 9. Whatever you do to one side, you have to do to the other. And again, I have a circle. But this circle, that looks like a D, but this circle here has a center of what? 0, 3. Yeah, there's nothing next to that x, so I know it's a 0. And then my 3. Good. What's my radius? Also 3. All right. So if you just have an r, in order to do the formulas in our toolbox, we know you have to square that. The same thing with your sine and cosine. You have to multiply through with that r in order to pull that off.